This is another batting order example. This is a continuation from the first example that we did. It says as an example 1, as coach of the Jets, you need to figure out the batting order for your team. But now suppose there are 14 girls. I'm just going to underline it here. 14 girls on the team instead of 9. If any of the 14 girls can be in the lineup, how many different ways can you make the batting order? So we still have 9 girls in the batting order, but now this time we have 14 girls to choose from. So just like we did before, I have 14 girls. I got 14 to choose from that could start off the batting order. Then I have 13 for the next spot on the batting order, then 12, then 11, then of course 10, then 9, then 8, then 7, then 6, and I'm not going to continue on because now all the batting spots have been filled. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So this is actually not a factorial because it doesn't count down to 1. The factorials will always count down to 1. This one stops. And since it stops, this is known as a permutation. And a permutation takes a factorial and tells it to stop counting off at a certain spot. And in order to demonstrate that, I'm going to go ahead and write this as a factorial to begin with. So then it goes down to 5, 4, 3, 2, and then 1. And of course, using the fundamental counting principle, we wind up multiplying all these values together. So now this becomes 14 factorial. But again, I want to stop it by the time we get to here. After the 9 positions have been filled, I want to stop it. So in order to do that, I'm going to write this as a ratio. And I'll put in 5 times 4 times 3 times 2 times 1. And of course, factors in the denominator that are in common with factors in the numerator will cancel each other. So I'm going to cancel these. And of course, there is our stop right here after the 9 spots. 1, 2, 3, 4, 5, 6, 7, 8, 9. So then over here, rather than write down 5 factorial, which is what this is, I want to write down my denominator here in relationship to the 14 girls. How do I do that? Well, I'm going to write that as 14 minus 9 factorial. And what's 14 minus 9? Well, that's 5 factorial, which is what this is here. So since I can do that, now I can express my permutation in this special type of notation here. We have this little subscript of n. N is the number size. That's our 14. And then we put in P here. That stands for permutation. And then I put in R. R tells us to stop the factorial countdown at a specific amount. So for here, I can write this as 14 permutates 9. So 14 here, here's my 14 factorial. And then I divide that by 14 minus 9 factorial. And what does that do? It tells my factorial to stop counting down after 9 times. And that's what's going on here. 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6. 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So what is 14 permutate 9? That's how that's pronounced. 14 permutate 9 comes out to be 726,485,760. That's a lot.